So my name is Mike Pinocchio. I own a company in Seattle, Washington called Network Protocol Specialist, and I do a lot of work. I do training for NetAlly, and also I do testing of copper and fiber networks. So we were talking with Keith and Fernay about some ideas, and they brought up cabling, and I said, well, here's some things I've run into, and he said, hey, why don't you do a presentation on that? And so I was thinking about, what would be a good name for this? And, so often we see focus on something like wireless, which is important, but if we can't get the data to the wireless access point, then it really doesn't mean anything. And so that's where the you can't spell wireless without wire really came in. And what we're going to take a look at is a number of things where we're doing some throughput testing. And what a big part of this is, I want to help focus you on what is really a problem and what isn't a problem. Because oftentimes we can focus on the wrong thing and still end up with problems. So one of the first things that we're going to take a look at this evening, and I'd put together all these PowerPoint slides on the ANSI TIA standards and things like that, and we decided, let's make something a little more entertaining. Because, well, it's the end of the evening, and you've been at other parties and so on. So Dan Klimke, marketing manager.
Director of Product Marketing.
Director of Product Marketing at NetAlly, brought up, he had heard that you could run Ethernet through bananas. And so...
Is it true?
I don't know.
Let's find out.
So what we did, just to give you an idea, because we can see that we have some bananas with wires stuck in them. Now, to make sure that this worked, and the fact that 100 meg Ethernet uses pairs 1, 2, 3, 6, we made sure to run 1, 2, 3, 6 through the bananas. So at worst case, we would get 100 meg. So just to let you know what we have set up, we have a NetAlly CyberScope on this side. We have a NetAlly LinkRunner 10 gig on this side. And NetAlly has an application that runs on there that is called LANBERT. And LANBERT is a tester that will send Ethernet frames across a wire and allow us to measure what kind of error rates we see for different data rates. So what we see up on the screen is that we have LANBERT set up, and prior to this, we tested a number of data rates. And here we have 5G base T. Now, 5G base T is designed to run across Cat6 Ethernet cabling up to 100 meters. So we thought, let's see if we can run it through 4 bananas. So I'm going to come in, and Dan's going to start the remote, and I'm going to start the generator right here. And we are sending packets through bananas.
Look at that. These are 5 gig bananas.
They are 5 gig bananas. Now, we figure if we send this long enough, we'll have banana bread at the end.
Ooh, I love banana bread.
But, so part of the focus of this presentation is that Ethernet is very resilient to things that are going on out there. And we saw, we started with 10, we moved up to 100, then those used 2 pairs. Then we moved to gig, we're using 4 pairs. Our data rates, our frequencies start going up. Cable requirements start going up. Then we go to 10 gig, but that's too much to run on Cat6, clear out to 100 meters. So we need to be able to run a higher data rate than 1 gig. So that's where 5 gig comes in. 5 gig is running at 250 megahertz. And we're running it through the bananas.
So putting the bananas in T568B.
Exactly.
Right? There we go.
Exactly. So one of the things that I wanted to really cover in this class is that there are a variety of ways of testing cable. I spend a lot of my time working with copper and fiber certification tools. And one of the things that we talk about when we do copper and fiber certification is that we are taking a very accurate measurement and we're comparing that accurate measurement to a standard. So ANSI TIA, ISO IEC set standards for cabling. And those standards, if you meet those standards, we know that technologies such as gig, 2.55, 10 are going to run across that cable. One of the things that we find, though, and this is where Lambert really comes in, is that the digital signal processing that we can do within the NICs is so much better than what those standards bodies anticipate. So they say if you meet these standards, we can guarantee that this is going to run across there. Well, we find that it doesn't take nearly what the standards bodies require in order to run that data across there. The problem is when we go in to test it, we don't know if we can really achieve that without going in and testing that. So the banana piece was more of just a
fun way of intro.
Zero.
Yeah.
What's that?
You should see the split pairs.
Well, okay.
Banana split pairs. Right?
Let's do one more. Oh, so the question was, what's the twist rate on a banana? And that was 0, no twist.
Yeah.
Now, one of the things that we tried, and I'll tell you what, Dan, why don't you put your finger right there?
Is this going to hurt?
No.
Okay.
Because I'm going to unplug this side. Oh, don't mess with the bananas. All right, so the one other test that we wanted to run on here before we put the bananas away is I have a PoE switch up here. So we thought we can get Ethernet through a banana, but can we get PoE?
Or banana bread. One of the two.
So we're going to plug that in. We're going to come back out here to the home screen. We're going to go to auto test. And
do you want me to stop Lambert over here?
yeah, you can go ahead and stop that.
Okay.
Let me come in here to the deep dive lab profile. And so I'm going to set this to class 3 PoE. And when it comes to running PoE, we have multiple classes, and those classes represent various current draws. And with class 3, we're looking at about 13 watts of draw of current on here. Now, one of the things that these tools do is they implement what they call true power. And with true power, not only are we measuring the voltage, but we're measuring the voltage when we draw that amount of current. And what that does is that lets us see what the impact of the resistance is in the cable on the amount of power we can get out of that. So I'm going to come back here, and we're still running through the bananas. Now, running class 3 power, we're only using 2 pairs. So when we start getting into some of the upper classes of power, we're actually using 4 pairs to send that power. Now, just as a note, when we're sending PoE, we're sending positive across one pair, we're sending negative across another pair. And when we're looking in detail at how PoE is going to run across there, one of the things that we really care about is the resistance imbalance between those pairs. Now, I didn't bring my certification gear to measure the resistance imbalance of bananas, but now I wish I did.
They're high in potassium, I hear. It might help.
So we're going to come back, and we're going to see if we can get an IP address through a banana and PoE. So in this case, we're running our test. We have gotten LLDP through the banana. Okay, so we can see that we're connected to port gig 3 of the switch. We got a DHCP address in 588 milliseconds, which would be interesting to compare to non-banana.
No PoE.
Okay.
All right.
Oh, certainly. I can run it again so you can record it.
3, 2, 1, recording.
All right, so we're going to come back, And we are going to run that again. Let me just click on the screen here. I'm going to hit start.
All right.
Now, what I will do is we may knock the POE down to class 1 and see if we can even come close to getting, and don't touch the
bananas.
So
Shaking.
So after we run this test, Dan will move the leads closer on the bananas to see if we can get any sort of POE. But we have gotten an IP address.
You can see our different test ports here. Those are test port.
Yep.
This is better than some real networks.
Well, and wait till we
Yeah.
show you. I mean, and that's the thing. There are some real networks where we can't get this out of it. Okay, move the leads closer
Okay.
together, Dan.
Wait, how are the ports labeled?
It's BAN.
Is that one?
It's really handy. You can just plug in anywhere on these things. All right. Closer.
Okay.
Well,
We got 44.6 volts out of our bananas.
that's bananas.
Okay, here we're going to hit start again. Okay, so now what we're going to do is we're going to get 2 voltage measurements. One is unloaded, where we're not running any current through the bananas.
There we go. Class 3.
All right, so we were trying to pull 13 watts.
Now let's try link application.
Can someone go to the gift store, get us 4 more bananas? We'll
Now,
stack them. There we go.
if we wanted to apply Ohm's law to this, we could go in and we could figure out what the resistance of the banana is, right? Because we know what the voltage drop was when we drew 13 watts. We're not going to do that tonight. But what we did was we got 5.4 volts out of the banana. That's not too bad. So what I'm going to do is I'm going to do one more thing. I'm going to drop this down to class 1 before we move away from this. And I really don't want to beat the banana
Excuse me?
demonstration too hard.
That's what. Not that there's anything wrong with that. It is.
All right, so we're going to run this test one more time using class 1. And I just can't find the cursor. There we go.
Okay.
So we're going to run this one more time, and then we will move on to
Oranges.
Aren't you glad it's not a banana? All right.
If you had the whole tree, would you support truck ports?
Spine and leaf.
Leaf.
So, when we reduced our current, the power down to 0.9 watts, we were able to get 9.2 volts out. So you could run a transistor radio off of this. Isn't
you
that
go.
what Gilligan's Island did?
The professor did this.
He
I know,
did.
I've seen it. Those were coconuts, though, right?
Yeah. All right. So part of this is to show how we can do some testing. But it is the other part is to show how resilient these technologies are and that we can run Ethernet through bananas. So a lot of where this presentation came from as well is last month a friend of mine down in Florida said, hey, can you participate in a webcast we're doing? He works for managed service providers and they do cabling installation and things like that. Oh, that reminds me, the one last thing I wanted to do before I finish that story is I wanted to run a wire map through the bananas. So we're going to put a wire mapper on the end.
Do I show what that looks like in the camera there?
Yes. So we've got a wire mapper right here, and the wire mapper, we'll get that
Whatever.
there we go.
Okay.
The wire mapper allows us to terminate the end of the cable so that we can look for open shorts, things like that. So I'm going to come in and I'm going to run a cable test real quick. I'm just curious to see if we can wire map through the banana.
Uh-oh.
Interesting.
Oh, that's my fault. I wired the bananas.
Oh, you wired them. You did not follow the 568A or 568B wiring standard, Dan. So in this case,
That's strange.
it really doesn't like that wire map.
No, it's...
And
Oh, you're not remoted in on this one.
oh, I'm sorry.
We disconnected from our remote session.
Okay. Yeah, we disconnected the management port when we hooked up the wire mapper. We'll come back to that, but
Yeah.
it didn't like the wire map. All right, so I think we're done with the bananas, Dan.
Oh.
You can raffle those off.
Yeah.
Those are
Grand-
for the raffle prizes.
Grand prize. All right, what's next?
The Ethernet bananas. Or,
All right, let's get that out. You want to go to the screw termination?
sure.
All right. I'm going to put this back into the corporate network patch cord kit.
All right.
All right. All right, next. Home Depot special.
Yes, so we're going to bring up the slideshow here real quick. So again, I really didn't want to go through a whole bunch of slides, but this is something I came across recently. And that's a door that those cables are running through. And so they had hooked up an access point and some PoE cameras. And this was the cabling they had. And so one of the issues that we run into quite often is people terminating cables and not using the strain relief. And so when we look at the cabling, one of the things that's really important is that the jacket extend all the way into the connector. Because what ends up happening is that the only thing holding these conductors in place is the little vampire teeth that come down from the pins. And those are not intended to hold the cable in place. So as we start working that cable back and forth, every time that door opens and closes, those cables are moving. And I've got some test cables that I'd set up where we stripped them back and we were showing that. But what we ran into was that the cable got progressively worse. Now, when we run power over Ethernet across a pair of cable, we are running positive across one pair and negative across another pair. And we come off of the transformer that's inside the NIC, and we're inserting the power into the middle of the transformer, and it's going both ways through that transformer into those pairs. Now, the thing that we know about electricity and water is that they will take the path of least resistance. So in a case like this, if we have one conductor that starts working its way loose and our resistance goes up, more current will flow over that other conductor, which the device at the other end will continue to operate, but we start saturating that transformer. More current is flowing one way than the other, and that starts affecting its ability to send that differential signal that contains the Ethernet through that transformer. And when that happens, we start seeing data loss. So one of the things that we see when we run into cases like this, where people haven't properly terminated the cables, is we start seeing a resistance imbalance, and that resistance imbalance eventually ends in data loss. Now, the tricky thing is that cable may have worked okay before we started sending PoE across it. But as soon as we start seeing PoE across, sending that across there, we start seeing a problem with it. So we're going to end the show. We're going to come back here, not this show, but the PowerPoint show. And what I want to show you here, let me plug this back in so it reconnects. So these are some screw terminal CAT or RJ45 connectors. Now, one of my neighbors, who knows that I do cabling and so on, came to me and said, hey, look, I'm trying to run this cable in my house. I'm stuck. It's stuck in the wall. I gave him a toner to help find it. But I said, Mark, do you have connectors to put on the end? He said, oh, yeah, I got connectors. I said, let's see them. And so he showed me these. Now, they sell these at Home Depot. And we'll just zoom in here a little bit. These have screw terminals on the back. So I thought, there is no way they're selling these as something for running Ethernet. So I found out online that my local Home Depot had 2 of these. So I went in and I said, okay, can I buy these? And that one we'll come back to. I said, can we buy this? Yes, we can. And so I looked on the back, and it's kind of hard to see, but it says compatible, I like the use of the word compatible, with Cat5 and Cat5e cabling. And I thought, how could they sell these things? So I bought both of them that they had, hoping that I would keep somebody else from getting them. But what I thought was interesting was that when we went in and tested those with a cable tester, it failed. It said this isn't going to work. So again, and let's grab a couple of patch cables here. When we hook these up and start pushing data through them, let's see how they perform.
Okay.
So there's that one. So I have a couple of Cat5e patch cords right here that we're going to plug in. Now, the thing about Cat5e over a short distance is we can get 10 gig out of it.
Do you want to go data rate 10?
Yeah, let's go ahead and force it to 10.
Okay. Started.
All right. So let's see how it works.
Mike, nothing's happening.
Oh, all right. Let's try 5.
Okay. Need more banana. Need more cowbell.
All right. So there we go. So it turns out that these screw terminals aren't any better than a pack of bananas. But actually, much to my surprise, even with the amount of crosstalk that we get with the screw terminal connections, we are able to get 5 gig out of those. So one of the things that we find is, and we could go through and run a number of tests. I was curious because somebody in one of my classes had brought up the little jelly bean connectors that they use in telco that have silicone in them. So these are waterproof connectors. So I thought, okay, let's stick some cables together there and see how those perform. And we could hook that up too, and we're going to get I think we're going to get at least 5 gig. Now, let's try it.
Let's do it, Mike.
So I've got 2 Cat6 pieces of cable that I've glued together with these jelly bean connectors. Let's set it to 10.
Okay. Going.
All right. So there we go.
Better
put
than
those-
bananas.
So there we're getting 10 gig out of that. We don't know if we don't test it, right? And so one of the things that I like to focus on is facts, right? I mean, today, talking about facts and assumptions. And we make assumptions about how things are going to work. And not that I recommend this. I would not want to see this out there in your network. But the fact is that when we get away from the ends, crosstalk has less of an impact on how that cable is going to perform. So the further away we get from the source, the more attenuation we see of that signal, and the less impact this crosstalk is going to have. So something like this in the middle of the cable is going to have a lot less impact than a poor termination at the end. And it's going to have more of an impact than a poor termination with a lower grade cable. So when it comes to cabling, Cat5e, Cat6, Cat6a are all designed to run up to Class 8 PoE up to 100 meters. So when it comes to PoE, it doesn't matter. Now, one of the big differences is when we start using thin patch cords. And I've got a lot of thin patch cords that I work with. These derate the link. So one thing to keep in mind when we're working with thin patch cords, they make it easier to dress out our cabinets and everything. But we have to take into consideration that that 28 gauge cable in there creates more resistance. When we increase the resistance, we generate heat. And so that is where this other picture came in. So let's come over. Let's go back here. Let's go back to this one. Okay. So when we were originally meeting, Fernay was saying that he had run into a situation where there was a cable that they were having problems with. And they went in to try and figure it out, took a while, but what they found out is that this cable had been zip tied to a pipe. And it wasn't any pipe, it was a hot water pipe, right? So hot water running through there was causing problems. So I thought, I can recreate that. So I took what's known as a permanent link. Now, a permanent link is the piece of cable that sits in the wall. The maximum length for a permanent link is 90 meters or 295 feet because we have to add patch cords to each end. So I took 295 feet of Cat6 and I put it in the oven. Now, I put it in the oven and I was pushing the buttons and my wife was in the other room and she heard the buttons and she said, "What are you fixing?" Because she knows I don't fix anything except nachos. And so I was pushing the buttons and I said, "Oh, I'm cooking Cat6." And she said, "Okay," because she's used to these kind of experiments going on. And the one rule I have to follow is I can't do anything that stinks up the house. So I had to find that perfect temperature that got the cable as warm as I could get it without gassing off, the insulation and making the whole house smell like, burned cable. So about 135 degrees. And when I did this, I brought in the certification equipment. Now at 72 degrees, this cable passed just fine. But it is right on the very edge of passing because it's at the very edge of the length limit. At 135 degrees, when it comes to what we know as insertion loss, and that's the loss, the attenuation loss of that cable, it failed. And it wasn't until I got my infrared thermometer out, it wasn't until that cable came back down to about 90 degrees that we started to see it start passing again. So what we find is that if we have situations where the cables are getting too hot, we start seeing attenuation. So when it comes to these thin patch cords, if we bundle those patch cords together, those cables that are in the middle are going to get warmer because that resistance starts heating it up, and the cables in the middle don't have anywhere to dissipate that heat. So as they warm up, the insertion loss goes up. And as that insertion loss goes up, we see our resistance go up, and as our resistance goes up, PoE goes down. So then we can start running into intermittent problems where devices are dropping power because we have too much resistance going out there. Now, I put together a little bundle of cable here, some different cables, and one of the ones that somebody at Amazon had to be laughing at when I purchased it, well, maybe they don't know, they don't care. And that is that in going through and taking a look at a number of different cable types here, so I just thought, okay, let's take a look at what some of our different cables look like. So, I've got a piece of Cat5e right here, and what we see typically with Cat5e is that there is no center spline. When we move up to Cat6, we see that we've got a center spline in this case, and that center spline helps keep those pairs separated. Now, just as a note, when it comes to the twisted pair, each pair has a different twist ratio. We never want two conductors next to each other all the time because that creates crosstalk. The spline helps reduce that crosstalk and keep those separated. Then we move up to Cat6A, and this is shielded Cat6A. It's got a mylar shield going around that. It's got the center spline. So before I did the presentation in January, I called a friend of mine that works for a cabling company who is very particular about things. And I said, Don, I'm going to ask you these things, and I know if I get even the slightest thing wrong, you're going to just pounce on me. And so I said, so when it comes to Cat6 and Cat5e, what's the difference? Well, we can run 5 gig all the way out to 100 meters with Cat6. But if I'm running gig or 2.5 gig, the biggest difference between these is how easy they are to install. And so what we start seeing is, when do I use Cat5e, when do I use Cat6? A lot of that's going to depend on do I have to pull it around a tight corner, is it having to go into a box, because with that center spline, that becomes much more difficult. Now, I don't know, did anyone ever go to Interop? You're old. You were there. So
They let 16-year-olds in then? Wow.
In 1995, I went to my first Interop in Atlanta. I sat through a class on packet analysis and troubleshooting, and I was hooked. And so 2 years later, I quit my job. I went to work for that company, and I started working at Interop. Well, we were doing a show in New York, and I had taken a red eye out there. And I got there, I was tired, and I walk into the show just to let them know I was there, and they said, okay, smart guy, you're the one that knows about cabling. We have a problem. Can you come look at it? So I went in, I took a look at it. I said, the problem is with the cable, not the connectors. And I started looking at the resistance of the cable. It's like that resistance is through the roof. What is going on with that? So this black cable right here is copper-cladded aluminum. And so what we find is that some, I'm going to call them unscrupulous manufacturers, will take aluminum wire and put a very thin coating of copper on it, insulate it, stamp TIA 568-2 They'll stamp it on there, and they will sell that cable. Now, I was doing some training in Singapore. One of the instructors that did the certification training was there, and he handed me a roll of cable, and he said, tell me what's wrong with it. I picked it up, I said, that's copper-cladded aluminum. And so that was kind of the initiation test, right? I had to be able to recognize that. But what we find is that people will buy it because it's cheaper. It says Cat6. The box that came in says Cat6 on it. Man. And if I'm just running it for Ethernet, it will work. But as soon as I take that cable and start running PoE, I have a lot of voltage drop, which results in heat and can cause all kinds of problems. So, in the cabling world, when do I really look at something like Cat6A? If I'm running 10 gig, right? If I'm running 10 gig, and in this case, when it's shielded, if I'm operating in a noisy environment, that starts looking very appealing. Otherwise, you know, these days, Cat 6, even Cat 5e. Now, price-wise, the most expensive part is the installation, so I would probably go with Cat 6. One other thing, oops, sorry, I didn't want to get in the way of your bananas. Another one that really comes into play in the wireless world is what's known as a modular plug terminated link. And so what we see is that kind of the tradition has been that we put a patch panel in, we put a biscuit up in the ceiling that's got a jack, and we run a short patch cord. But more and more, what we're seeing is where we have an RJ45 jack on one end and an RJ45 plug on the other. And this is known as an MPTL link, a modular plug terminated link. Now, if you ever get an opportunity to specify cabling, what I'm going to ask is that you specify that it shall be tested to MPTL. Because a lot of the testing that's done ignores this plug at this end. And so we can have very poor performance for the plug on this end, and it will still pass. And that's where I have a cable where it's stripped way back. The MPTL test does require that we test that and make sure that's good. And the one other thing here is this is what's known as a field terminated connector. So instead of crimping the connector down and having those vampire teeth come in, we are actually crimping that down, but it's more of a termination like we would see with that jack right there. Now, when it comes to testing, let's move a couple things here. I did a series of days of training. Let's see if we'll rotate that around. We'll flip that. We'll flip that. Boy, there we go. Okay, so I did a class and I said, okay, if you're working with fiber, you have to know what the optical signal level is. So I went out and I bought this $29 optical power meter off of Amazon. And it came with this little dongle right here so I could test copper. So I said, okay, well, let's grab this link
Pardon my
right
bananas.
here. And I've got this cable. And part of this came out of this friend of mine that was doing this webcast series and doing the, for managed service providers. I said, when they install the cable, how are they testing it? And he said, we're using a wire mapper. So I'm going to plug the wire mapper in here. Plug the wire mapper in. All right. So we plug that in, we press and hold the DB button, it says RJ45, and you can see the little lights flashing across there. So, okay, cable's good, right? Is it? So, Dan, why don't you go ahead and plug that in into your end over there. So I've got some Cat 5e cable. We expect we should be able to get 2.5 gig out of that.
Going.
And we'll come over here, we'll bring that up. I'm going to set this to 2.5. Oh. And I'll hit start. You ready?
Yeah, I don't remember if we were on 5 or 2.5. Hang on. Stop. Yeah, we're on 10. 1 second. Going.
Okay. Huh.
But the cable was good.
But I thought I thought the wire mapper told us the cable was good, Dan.
You get what you pay for, Mike.
So I'm going to do this. Let's see. Let me just connect this to my network here real quick. I'm going to connect wirelessly. No, you don't get to see that. One, two, three, four. Bananas. Okay, so we're going to connect via wireless here real quick. 226. All right, so this way I can show you the wire map on there. All right.
Oh, you want to just do it patch cord test?
Yes. So we'll put the wire mapper on the far end. And we'll run a cable test on that. Oh, we'll plug that into
Oh,
the
yeah.
wire mapper port.
That helps.
Yeah, why not? All right. So what this does is it comes back and says split. Anyone know what a split pair cable is?
Banana split.
What's that? They're not in the pairs. So 568 or T568A and T568B says that pair 1, 2 shall be used for one pair of Ethernet, 3, 6 another, 4, 5 another, 7, 8 another. In this case, this cable is wired so it has continuity from one end to the other, but the data pairs are not on the same pairs. So what it does is it turns it into a piece of flat cable. When I first got started in network troubleshooting, I was called in by a router manufacturer at the time that said, we're having all these problems, can you help us figure it out? I walked in and the first thing I saw when I looked in there was a big spool of silver satin phone cord, 8 conductor, with a big box of connectors. I said, I don't need to tell you anymore. I said, get rid of that, rip every one of those cables out. So what this has done is this has removed the impact of any twist. This cable now is totally parallel, and we see a massive amount of crosstalk going across there. So when it comes to doing testing, using a wire mapper doesn't do it. It's not good enough. We need to make sure it's wired properly.
Is split pair anything like banana split?
A little less tasty, in my opinion.
All right. So there's one more I want to show you because I love these. So these are some flat Ethernet cables. Okay? Cat5, they say Cat5e on them. So what I'm going to do is I'm going to plug these into my Ethernet switch up here. And I'm going to plug one port, one of them into this tester. I'm going to plug the other one into this tester. Let's see. Actually, grab that gray cable for me.
Okay.
I think this will display better. Put that on one end. So let's start Lambert. We'll start it for 2.5, which I think it's already at.
Let me just check. Yep. Started.
Okay, so we're running 2.5 gigabits per second through here. I think.
We're running 2.5 gigabits.
Well, let's do 1 gig then.
Running.
Okay. So we're running traffic and everything is going fine. But watch this.
Here, I'll do the,
So watch what happens as Dan moves the cable around. What do we see? We see our errored frames incrementing. So this is a case where we've got some cables that are rated at Cat 5e. They seem to be working okay. We do an iPerf and it all works. But as that cable moves, it changes the orientation of those pairs to each other. We start seeing crosstalk and we start seeing data loss. So one of the things that I did in preparation for this, and I've got a slide I can show you, but if we have this connected up to a switch, these show up as FCS errors. So one thing I'm going to ask that you do is if you are working on a network and you look at a switch port and you see there are FCS errors, and let me bring that slide up, because it's really, really, really important to me. Let's see. Come down here. Distances. All right. So this one right here. This is in my hotel room. I'd hooked this up. But here we start seeing these FCS errors. Kind of as a last note, FCS errors are never acceptable. There's no amount of packet loss, FCS errors, I expect to see. I could go through my whole network and not see any, and can see billions of packets running across there. When you see this, it's time to start investigating what's going on with that link. And that is a physical layer problem. That means that a packet arrived with a corrupt FCS, or the FCS didn't match what was calculated, and it was thrown away. And what does TCP do when that happens? Retransmits, right? And if I have a low data rate, I may have to wait my retransmission time to retransmit that. Nothing will have more impact on your data transmission than lost frames. So, and it doesn't retransmit as fast as wireless does. It takes a while. So when it comes to looking at switches and so on and doing that troubleshooting, if I'm looking at a link that is having poor performance, one of the first things I do is take a look at this.